Welcome to the Middle Room Workshop. Today I'm going to show you how to configure the Rotary Attachment RA2 by XTool, and then I will also show you how to set it up with the software both LaserGRBL and LightBurn. Without further ado, let's get into it. This video is going to be a little bit too lengthy, so if you are interested to some particular section, have a look to the timeline below and you can freely jump directly there. Alright, so now let's get to the video. Alright, this is pretty much what you get in the box beside the user manual. And here you get pretty much everything that you need, including the tools. Now, I will pop things out as we go along so that you can see also where to locate them. Alright, so here you will find the actual rotary tool. So this is the actual machine. So I'll put this out of the way. Now, once you get this out of the box, you are pretty much able to work with it. So all you will need to do is to get the cables to connect one hand to the rotary tool itself and the other hand to one of the cables that goes to one of the stepper motor of your machine. I will show you later on how to actually do that. And so in this configuration, this is a roller configuration. You can basically adjust the roller in 3 different positions so that you can work out object starting from 3 millimeters in diameter in this tighter position to greater than 60 millimeters. I'll put up on the screen the infographics from XTool website. So how to actually widen this up? So all you will need to do is to keep this roller fixed, also because this one is actually attached through the timing belt through the belt to the stepper motor. And so all you need to do is to reposition this roller over here, which is done simply by unscrewing this support from the bottom. Now, as I said, XTool provides the 2 hexagonal key required, but if you have an electric screwdriver, it will be much easier for you. So I will use that actually. So just unscrew. And once you're done with that, I found that the easiest way is to lift this off and then to pull this along. Exactly in this way, without popping it out from here, because then it's a little bit of a pain to put it back in because of the belt inside. So if this comes off, just stick it back in and put it on its place. And now it is time to screw back to fix the support. There we go. So once you have your desired width, you can take any cylindrical object and you are basically good to go. So you can see that I'm going to rotate this one and you are basically good to go. But there we go, this one popped out, so you are ready. You can use the roller in conjunction to a support in order to work out longer items, and so I'm going to show you that now. So this is the support that you get, and this support can be used in conjunction to any attachment actually to work longer or awkward shapes. So I can get, for example, this roller. Now this is wide right now, so as you can see the handle, it's touching here. So what you can do is to take it all the way so that it's clear, and then to use the support to rise it at the right height, and you are basically good to go. Now, one thing that you want to make sure when working with it is that you want this perfectly parallel to the axis, the axis that is going to move back and forth. so along the longitudinal axis of your cylindrical object. And so XTool provides a spiral level here that is very handy. You can put it on top and you can see that it's going to show whether or not you are leveled. All right, so now the second attachment is the chuck, and this is where things get interesting. Now, in order to install the chuck, you will need to first install this pulley. So that's the first thing that you will need to do, and you will need to do this pretty much once. Now, one note, I found this, it was very hard to actually stick in. In fact, I had to hammer it with some wood in order to protect it, and I don't think this is going to come out without an extractor. But there is no problem, because once you set it in, you don't really need to take it off. So now, to use the rotary tool, it is recommended to remove the rollers so that it's not on the way. And so let's do that right now. Again, from the opposite side, this time we are going to unscrew both rollers. Okay. Now one's come out. Now the fixed one has a collar. That was actually easy. Yeah, basically you have here another screw that you have to loosen in order to pop this out, because this one has a key slot here. Now this is the chuck attachment, so you get one belt and the device itself. All right, so what you will need to do, you will need to wrap the belt around the large pulley and then to stick it onto the smaller pulley. And then you can see that here there is a little bit of recess, so you're basically forced to come here and then just sit it there. Then you will take the two long screws that were provided, throw them in. Now in this case I'm going to use the manual tool that they provided because it's a little bit longer. And then all you need to do is to simply screw and fix the chuck. There we go. Now we are fixed and the chuck is able to rotate. Okay. Now here with the chuck you have various attachments that you can put in, and so this is where you get them. So first of all you get a standard key for the chuck to operate, and then the jaw attachments. Now XTool provides a two-step attachment and a single-step attachment, and they can be installed either ways, so either like this or like this, and it's all dependent on what kind of object you need to grab on. And so I'm going to fix it on one direction so I can show you some. So let's take all of the others. They have to be all the same, obviously. And let's take the smaller screw over here. Now you have one pair of screw for attachment. However, I am going to fix only one, so it's just for demonstration. So let me change my bit. There we go. Now, as you can see here, you have 4 threads, 4 threaded holes, and here you have 2 holes. Okay, so you will need to see which one is better. So I'm going to use the middle one. There we go. Going to now fix the other one. If this is too tight, just release the chuck. Try obviously to do them all equal. Otherwise you are not going to get this to center anything. Now you can easily operate this by hand, as you can see over here. And then once you are close to the object, you can use the key. Here there is a small hole where you can apply this and to tighten up the chuck. So let me show you what we can grab on. For example, if you want to do a pencil, this is a perfect example. You will just put the pencil in, and there we go. That's actually been engraved with this tool. So once you are happy with it, you will want to verify that this is pretty much level. So when it rotates, it doesn't wobble back and forth. So once you're happy with it, you can tighten this up. You don't need to go crazy with it, just a little bit, so that it keeps the workpiece in place. All right. Similarly, you can grip onto inside feature. Let me take, for example, the cylinder. Let's see if this is going to be sufficient. And as you can see, we are grabbing on this. Now, things that you can do with the chuck, beside gripping stuff directly onto it, you can use the tail support, which is this thing over here, which you find in this box over here. And you will just slide this in. And once you find a position, you can lock it. And one way to show you where to use this, it's with spherical object. That is actually why it was designed in the first place. As you can see, this is conic, so it holds very well onto cylindrical object, and is also spring loaded, so they did it smart. And so I will show you now how to use that. Now, all of the attachment will work pretty much the same, so I'm not going to show you the other side. You will simply need to experiment with it until you find the right orientation and dimension that suits you. The cool thing about this product is that you can create your own custom attachment for the chuck. And in fact, XTool provides 2 additional ones, which are larger, that you can 3D print if you have a 3D printer, or you can 3D print through some 3D printing service. And so they are made to grab onto bigger things. So let me show you now this in combination with the chuck. So you will get these 3 rods. Now these 3 rods, they are designed for multiple purpose. And now I will show you what exactly. I'm going to screw this in like this. You can use a spanner here to tighten it up, but I haven't been using it. I think there is absolutely no need. So let me widen this up. And now what I can do here, I have already engraved this ball. I can stick this inside, and then I can use this tail support to hold onto it. Okay, so let me leave a little bit of tension, and then you use this small setter here to set everything up. And now, as you can see, this is going to spin accordingly. So that's how I actually did this one. Okay, now how about if you have larger object? I'm going to show you that. Let's remove these rods from here. So we are going to install the larger accessory here for the jaw, so that I can show you what I want to show you. Again, choose the hole that suits the most. There we go. So now this is a larger setup, and we can grab onto larger things, as you can see. Then we can use the key to tighten things up. And now here you will notice a problem. The handle is going to inevitably crash with the frame. So XTool have been thinking about this as well, and you can basically turn the entire module here, the chuck with the motor, all the way around. So I'm going to show you that. So let me release the mag first. We are not going to damage it. So in order to do that, you will need to release these two screws. There we go. And then to turn the entire module all the way around. So let me see. Okay, so release everything, and now you can turn this one around. Okay. All right, so let's once again put on our mag. Now here you will run also into instability issues, and still you might not be clear enough from your text. So what I suggest you to do is to first thing first, you are going to boost up your rotary attachment with a couple of pegs like this one. Okay, so that your workpiece is actually clear. And then another thing that I recommend you doing is to get some weight and put it on the back. There we go. And now we have a stable attachment here. All right, so once you are done configuring your rotary tool based on the object that you need to engrave, it is time to set it up with your machine. Now, this rotary tool will work with pretty much any machines. The only attention you have to pay to is the wiring. And so you will see in the package you get basically a long wire plus a couple of adapters. And if you look at them closely, you will see that basically one adapter has 4 cables straight, and one instead has 2 inverted cable. And so some machine will need one cable type, some another cable type. But you will understand that right away once you plug it in, because if you use the wrong wiring harness, you will basically hear some strange noise, like if the rotary tool is stuck. And so if you hear that, nothing to worry about. Now, what you will want to do is, first of all, let me turn this machine around. You will want to take the cable that goes to one of the stepper motor. Ideally, you want to leave the x-axis to do the engraving job. So this is the fast axis. And so you will want to target the y-axis. So you will simply unplug the cable here, okay? Then you will take, in this particular machine, I found that the straight connector is fine. So you will plug this in, and then you will plug this from the other hand inside here. And then this now is ready to plug into the stepper motor of your rotary tool. So once you've done that, you have the actual setup to take care. So as I said, this will work with pretty much any machine, but the reason why I have decided to use this Atomstack P9, it is because I found that the open frame, you know, it's one hand is basically free. It makes it much easier to stick your object in and out, and the rotary tool as well. And so this is, I think, optimal. And the other reason is because most of my other machines, they are attached to an MDF base, and so I didn't want it to detach that from there. So what you will want to do is first boost up your rotary tool so that you know what reference height you will need. And so I will do that right away. All right, so now let's turn this around, and you will see that I need a lot of clearance over here. So we will need to boost up now our machine. Now, if you have this machine from Atomstack, you know that this machine comes with the boosting kit. It was included basically. They are pieces of plastic legs. However, they are very light, and in my view, they are not very stable. So I went ahead and prepared a bunch of this scrap. I just clean it up, and I'm going to put it up here. Okay, now you will set it up properly to avoid anything falling down while it's in operation, but you got the idea. Now, as you can see, I'm cleared of it, and I can bring the rotary tool under for engraving. All right, so once you settled everything up and everything is correctly wired, it is time to turn on the machine. Now, before to do that, though, I would recommend you get the rotary tool with any object attached to it farther away, and that's because at the moment when you turn on the machine, if there is an automatic homing enabled within the software, basically you will have the laser module pushing towards home, and since the software doesn't know that actually the y-axis now is our rotary tool, you will also have the rotary tool spinning, which will end up crashing against the laser module or any other part of your machine if it is too big or if it is too low. And so with this out of the way, we can now actually power on the machine. And so as a start, I'm going to show you how to set everything up in LightBurn, which is the easiest, and then we will step over to LaserGRBL. All right, so in LightBurn, I'm going to select the machine. So this is the Atomstack P9. It is automatically detected, and as I mentioned, the rotary tool is going to spin, and so this would have resulted in an inevitable crash within the object and the machine. Now, once we are done, if this is the first time for you setting up a rotary tool, you will need to first of all show up a switch or a toggle. So we can go over to the settings here, and over here you will see there is show rotary enable on main window, and give on OK. And so now you will have a rotary enable toggle switch. Then you have to set up your rotary tool, and the setup consists on inputting some parameters. Now, if you don't have this over here, you can find it under laser tools. Okay, so laser tools, rotary setup, and that would have been the same one from this button over here. Now, depending on what configuration you have configured your rotary tool with, you will either choose for a chuck or a roller. And then the enable rotary, this switch here is the same one like this one. All right, so now let's start with the roller. Now, if you're going to use the roller, you have two mandatory parameters that you have to input inside. And so one of it is the millimeter per rotation, and that is going to be 40.35 millimeters. And the other one is the roller diameter, which is 17 millimeters. Okay. Now here you have object diameter and circumference. These are not mandatory when you are in roller option. Okay. Then the other thing that you will want to do, depending on which axis you are actually using for your rotary tool, you will need to select the axis there. So most likely you will have unplugged the y-axis stepper motor, and so that's basically going to be your y-axis. But for example, if you're using XTool machines, this will end up being the z-axis, and so you will need to do that accordingly. And now, once you're done with that, you can click on OK. All right, so let me now show you also how to set up the chuck before stepping next. So here you will need to click on chuck, and you will see also the infographic is changed. Again, which is the rotary axis. In our case, I believe that is unchanged. And so here instead the mandatory parameter is again the millimeter per rotation, which is 160.14. And by the way, this parameter can be found on XTool website. And then this is the one thing to keep in mind when working with the rotary tool. So when working with a roller, there is no need of inputting the object diameter and circumference. As you can see over here, they are optionals. It's just a simple calculator. However, when you work with a chuck, that is actually required, and so you will either input the diameter or the circumference of your object. Either ways will actually give the other value. And so, for example, I have already measured my mag, and I know that that's actually 250 millimeters, so that's basically 79.577 millimeters in diameter. Okay, so once you're done with that, you can click on OK, and then you can input your design. So put it on the orientation that you want. Now, in order to be able to use the rotary tool, you have to work in current position, also because it will come much easier for you to position that. And I do recommend using the horizontal center origin, so either from the left, from the center, or from the right. So either ways will be all right. Of course, you will need to take that into account when positioning your laser. Okay, and so now, for example, let me get this. Let me scale it down, say to 30. Okay, so I can show you this in preview. You can put the mag under. You will position yourself wherever you want the engraving to be. And by the way, the measurement will need to be taken on the center position of where you want the engraving to be. So once you are happy with that, actually, let's give us a little bit of room. You can position the laser. I mean, you know how to do that already from regular engraving. Okay, let me give a little bit back, so we are not going to crash. This is very important. You will want to pay attention that nothing crashes while the machine is operating. Okay, and in fact, I've been using this machine with the Neje laser module because it has a longer focus, and so there is more clearance down here. All right, so once this is ready, we can come over here and to click on preview. So as you've seen, this one just crashed. So this is something that you will need to take into account, especially when you have the jaws or the handle on the way. Okay, one last thing that I want to show you in the rotary setup is that you have for both the chuck and the roller the mirror output rotary. So this is something very important before to actually go for an actual engraving. So before to engrave on something that you don't really want to waste, I would highly recommend you to test it out with some lettering. And so what I ended up doing is to grab some of this cartoon roller, which you usually find in kitchen stuff. I don't know what used to be, maybe kitchen paper or something. I put it on either on my chalk or on the roller, and I'm engraving something, for example, my logo, Middle Room Workshop. So I see the lettering, and if the lettering comes out mirrored, then that means that I need to mirror the axis, or I have to unmirror the axis. It depends from the current state and the output. And so with this out of the way, now I'm going to show you how to do the very same thing in LightBurn. Okay, so now let's connect the machine, and they should automatically home. it actually didn't happen. So let me unlock the machine and let me try homing it. Yeah. All right, so that is going to try to seek for home but will not find home. So you will see here homing failed. Okay, now unfortunately LaserGRBL does not offer an option for rotary tool just yet, and so in order to actually input the parameters or any way to set up the software to work with the roller, you will need to dial in and change some parameters in the GRBL config file. Now, if you are going to use the rotary tool with your rollers, with the rollers only, you don't have to do absolutely anything except for switching the axis direction or rotation in case you see that the things are getting out mirrored. Instead, you will need to change one parameter if you are going to use the chuck. So let's go over to GRBL config. Now this is reading from the actual MCU, the microcontroller. Now the parameter that you want to look at is the $101. This is the y-axis travel resolution. Now this will be standard for 80 steps per millimeters. And now you will want to take note of that because once you finish working with the roller, you will want to put that value back as it used to be. Okay, eventually you can also export and to have a backup file for your configuration just in case something goes wrong. Okay, all right, so now here you will need to input the result of a calculation, and that calculation, let me launch the calculator. The calculation is going to be 12,800 divided the circumference of your object. Now I know that my object is 250 millimeters, so 51.2, and so I'm going to double click here and input 51.2, and then I can either click anywhere or just click on write. So config written successfully, then I can close. Yes, let's rewrite everything. All right, and now what I can do, I can try to see my rotation direction. Now the direction is rotating has absolutely no meaning on whether it is correct or not. You will need to test it, so to see if the things are right with your specific machine. Okay, now if out of your test things are not coming right, okay, that means you will need to rotate the direction of the axis, so you will need to go back to GRBL config. You will need to look for the third one, so $3, which is step direction invert. Now this is a mask value, not getting into that, but in order to switch your, in this case is a y-axis, we said, if here you are finding 1, you are going to input 3. If you find 2, you are going to input 4. Okay, I will note that in the video. So let's click on write and close. Yes. Now let's click once in one, once in the second direction, and then we should see that when we click, the direction should be inverted. And this is the way you go about it. As per the design, everything is unchanged. You will import your design and you will set it up the same way you would have do a classic, typical planar job, 2D job. Now, one thing to notice here, it is very, very important. Before you start doing a regular job, 2D job, without the roller, you will need to set these parameters back the way they were. Otherwise, you are going to mess up with it. So the direction pin, it was 1, and I'm going to put it to 1. And then what else? It was this one, 80. Oop. And once you're done, you can write. So to config written successfully, close. Yes, right. All right. So, and this is the way you go about it. Of course, if you are using an XTool machine and their proprietary software, things will be much simpler, but as you've seen, we set it up with a different machine and we used the two most common controlling software and we had absolutely no problems. Now, I hope you found this video helpful, informative. If you have any comment, leave them in the comment section below. Click the thumbs up button below if you like the video, and don't forget to subscribe to my channel if you want to see more videos like this one. Ciao for now!